Hello, today we are going to have a look at the following equation. X squared plus x equals 3 to the power of y, where both x and y are integers. First, let's see if we have any other restrictions on the variables x and y. So for now, we know that x is an integer. That means that x squared plus x is an integer as well. But that in turn means that the right side of the equation, meaning 3 to the power of y, must be an integer as well. But if 3 to the power of y is an integer, then we can deduce that y is greater than or equal to 0. Indeed, if y is negative, then 3 to the power of y will be a fraction. Now, let's discuss the parities of the left and right sides of the equation. By saying parity, I mean even or odd values that the expressions can take. To discuss it for the left-hand side, let's factorize it. So we have x squared plus x. Let's factor the x out to get x times x plus 1. Now, x and x plus 1 are consecutive integers, meaning that if x is even, then x plus 1 would be odd. And vice versa. If x is odd, then x plus 1 would be even. As you can see, in both cases, the product will be an even integer. So we know that the left-hand side of the equation is always even. Now, let's move forward to discuss the parity of 3 to the power of y. We know that y is greater than or equal to 0. So we have two cases. 3 to the power of y is just 1 if y is equal to 0. And is some product of 3's, exactly y times multiplied with each other if y is greater than or equal to 1. See that in both cases, 3 to the power of y is odd because 1 is odd, and the product of 3's is odd because 3 is an odd number itself. So we have that the left-hand side of the equation is always even, and the right-hand side of the equation is always odd. As their parities are different, then we can conclude that the equation has no solution on the domain of integers. No solution. Thank you for your attention. See you next time.